Hey guys, how are you all? So today we are going to discuss the nature of CX bond. We already taught till this in text questions. Okay, check the video 1.1. Okay, this is 1.2. So halogen atom is more electronegative. Halogen atom is more electronegative. Am I right? The halogen atom is more electronegative compared to the carbon. Okay, so if it more electronegative, the halogen is more electronegative, it means that the electrons slightly move towards the halogen then compared to the your carbon. Okay, so this is polarized one, becoming negative pole and positive pole, we can call it as the polarized one, right? Then when it comes to the bond length, okay, when it comes to bond length, the CIE bond length is more than CBr, then CCl, then CF. Why? Because if you are moving fluorine to chlorine, the size get increases. Okay, so the internuclear distance get increases, so bond length get increases. Clear now? Okay, right. Because of this polarization, your haloalkane going to have a dipole moment. Your haloalkane going to have a dipole moment. See here. So they given the bond length. Okay, so when we are moving fluorine to iodine, the bond length get increases, right? Bond length get increases. Then CX bond enthalpy is also given. So bond enthalpy nothing but bond energy, right? Bond enthalpy nothing but bond energy. So bond energy get decreases. Bond energy get decreases because if I take the CH3F and CH3Cl, so in this the carbon and fluorine very close with each other, we are not able to break easily. It requires more energy compared to breaking of CCl bond. Clear? So this is the first point. The second one, look here, the dipole moment get decreases from the fluorine to iodine, but there is a one exception here. So if I am taking the CH3F and CH3Cl, if I am taking the CH3Cl and CH3F, so CH3Cl is more dipole moment in case of dipole moment, and the CH3Cl is more compared to CH3F. Okay, CH3F. Why is it so? You know very well, the dipole moment is nothing but the charge and distance, right? The charge we can say Q, right? So in this case, the charge and the distance is more in case of CCl compared to the CF. That is the reason why the dipole moment is more in case of CH3Cl compared to your CH3F, right? Next we go for the preparation. The first preparation we can start. Okay, in this case we are preparing your alkyl halide from the alcohol. Okay, so if your alcohol is tertiary, that is more reactive than secondary than primary. Okay, the tertiary is more reactive than secondary than primary. Clear? So the first reaction, that is Lucas test. The first reaction, Lucas test. Look here, the first reaction. So if I am taking the CH3, CH2OH, if I am taking the CH3, CH3OH, then I am taking the CH3, CH3. This is secondary, sorry, this is primary alcohol, this is secondary alcohol, this is tertiary alcohol. If I use the Lucas reagent, zinc chloride and HCl, here we need not require zinc chloride, but we need only concentrated HCl, the reaction going to happen. So here there is a formation of your tertiary chloride. Then here we require zinc chloride and HCl. So here there is a formation of secondary chloride, but here there is no reaction. We have to heat, then only the reaction is possible. This is all about the first reaction. When it comes to second reaction, we know, right? the ROH plus NaBr plus H2SO4. Okay, so this is Na plus, this is Br minus. When it comes to here, this is OH minus, this is R plus. Okay, this minus going to join here, this minus going to react with H2SO4, then it going to form the RBr plus NaHSO4 plus H2. Okay, H2O. When it comes to the third reaction, in the third reaction, we know that PX3 is there. Instead of PX3, what I am going to take is, I am going to take PCl3. Look here, there is a ROH. How many ROH is there? 3 ROH is there. Okay, so 3 ROH is there. Okay, so here PCl3, as I told you, Cl. This is also nucleophile. So this nucleophile attack the alkyl group, automatically your OH get removed, right? So this 3 OH group going to connect with phosphorus, then what it going to form? H3PO3 it is going to form, then rest of the product is 3RCl. Clear? When it comes to ROH react with PCl5, ROH react with PCl5 at the time. Look here, Cl, then phosphorus, Cl, then Cl. Okay, this RCl get become R, then HCl. So what is the product? It's going to be RCl plus HCl plus POCl3. Clear now? Right. Next, it is going to react with red phosphorus. Then red phosphorus react with whatever the halogen, it is going to form its alkyl halide. Then one more reaction I will explain to you in the simple way. That is your alcohol react with SOCl2. Your alcohol react with SOCl2. Right? Look here, ma. So this is your ROH. This is your Cl. Okay, this is react with this one, this react with this one, then there is a formation of RCl plus S42 plus HCl. But this is very, very important reaction. Why it is more important? Because in this the pure form of RCl is formed, because rest of the 2 byproduct are evaporate. Okay, clear? All this reaction which is possible, okay, all this reaction possible only in case of alkyl alcohol. This is not possible in case of aryl alcohol. In case of aryl alcohol, we know that there is a 2 lone pair of electron present over the oxygen. This lone pair of electron undergo the delocalization. Okay, so it became a partially double bond. Right? So due to delocalization, your carbon and oxygen bond become a partially double bond. So we are not able to break it easily. So whatever the reaction we discussed till now, this reaction is not possible in case of aryl alcohol. Clear? So then there is a free radical reaction is there. Right? So your free radical reaction, the chlorination and the bromination is possible. We will discuss one by one. Look here. See, they taken the butane. So butane, I will write it in the bond line formula. So if it halogen come here, 1 bromobutane. If it halogen come here, 1 bromobutane. If it come here, 2 bromobutane. Here if it come, 2 bromobutane. Okay, so there is a 2 product is possible. Now what I am doing is I am using the Cl2, okay, in presence of sunlight, or we can use the heat also. Right? So in this case there is a 2 product is possible. Okay, so one is in case of 1 chlorobutane, here 2 chlorobutane. Okay, this is all about the second reaction. When it comes to from alkene we will start propene. Okay, in this propene, in unsaturated alkene, we have here one hydrogen, here two hydrogen. I will tell you why we need to know the number of hydrogen present in the double bond, right? So if I am taking the HX, so this is positive part, this is negative part. According to Markovnikov rule, your positive part goes to the unsaturated alkene which has the more number of hydrogen, the negative part goes to the unsaturated alkene which has the less number of hydrogen. So what is the product it is going to form? It is going to form 2-chloro 2-halo propane. It is going to form the 2-halo propane. When it comes to the third reaction is very important. I will tell you why. So look here. Now I am taking this symmetrical alkene. Why it is symmetrical? We are able to break it into 2 half, exactly 2 half. So then I am using the bromine water. Okay, bromine in CCl4. This color is reddish brown color. Okay, so when this Br react with your symmetrical alkene, at the time your color get vanished. Okay, so this is your colorless product. This is colorless, but in case of this one, reddish brown color, right? Okay, next we are going to solve the sums. Okay, so what is the sum? Identify all possible monochlorostructural isomer expected to be formed on the free radical chlorination. We discussed already this question, right? So look here, one more time I will solve it. Okay, this is your given alkane, right? In this we are doing the monochlorination, right? So these two are same. Then one product, then second product, then third product, then this is fourth product. Okay, all 4 product we can write it. So you tell me the all 4 product name in the comment box. Okay, right. Next we go for the halogen exchange reaction. When it comes to halogen exchange reaction, there is a 2 reaction that is there. We can discuss one by one. Look here, first one is Finkelstein reaction. In the Finkelstein reaction, what is the second word? Iodine. So we are going to prepare the iodoalkane. If I am taking the Rx, the X might be chlorine or bromine. It react with Ki. What it going to form? It is going to form the iodoalkane plus Kx, right? This is the first reaction. In case of second reaction, that is Schwarz reaction. So Schwarz reaction, again I am going to take the haloalkane. So it might be chlorine, it might be bromine, but it react with silver fluoride or mercury fluoride or cobalt fluoride, or it is antimony fluoride. Any one of the reactant, it is going to react, it is going to form the your fluoroalkane. Clear? Okay, we are going for the reaction, that is your preparation of haloarenes. We know that, right? We all know that the benzene which is connected with CH3, we know that, right? This CH3 is activating group means what it is going to do? It is going to increase electron density on ortho para position. Okay, since this is electrophilic reaction, your reaction going to be on ortho and para position. So your product going to be your ortho product and plus your para product. Clear? But what if I am using halogen, what if it F2? If I am using the F2, this reaction is more vigorous. Okay, so it is highly reactive. We are not able to make this reaction highly reactive in case of F2. Okay, what if in case of your toluene react with I2? Okay, this reaction is possible. This reaction is possible. There is no second thought, but the reaction is reversible. This reaction is reversible. In order to restrict that, we are using the oxidizing agent HNO3 and HiO4. Clear? This is all about the first method preparation of haloarenes, right? When it comes to second method, from the aniline we are making. Okay, so second method, the preparation of haloarenes from the aniline. Haloarenes from the aniline. Okay, what is aniline? Benzene, if it connected with NH2, then we call it as a aniline. This is aniline. Okay, this aniline react with sodium nitrite, NaNO2, then hydrogen halide in presence of 273, 278 Kelvin. At the time there is a formation of your benzene diazonium chloride. This is, what is this? This is benzene, this is diazo, this is chlorine. Okay, so then we call it as a benzene diazonium chloride. Clear? Right. This benzene diazonium chloride react with halides in presence of catalyst. So this is your benzene diazonium chloride. This is going to react with your cuprous halide, Cu2X2. It is going to form your haloarenes, right? Your halogen might be chlorine or bromine. Okay, in case if you want here iodine, what I am going to do is, this is going to directly react with Ki without this cuprous halide. Okay, so it is going to form the iodoalkane. Clear? Okay, so when it comes to next reaction, look here. So this is the question, we are going to discuss it. Okay, look here now. The first reaction, this is based on your Markovnikov rule. This is Markovnikov rule. This is anti-Markovnikov rule. So we have CH, double bond of CH2. So react with HBr. So H plus Br minus, H plus goes to here, Br minus goes to here, right? So we will get this product. Next we go for the another one, that is but-1ene, right? So CH3, CH2, CH double bond CH2. Here 2 hydrogen is there, here 1 hydrogen is there. So it react with HCl. So H plus Cl minus, right? So H plus go to CH2, Cl minus goes to your CH. So what it going to form? CH3, CH2, CHCl, CH3. Clear? Okay, so this is the second. The third one is this one is your anti-Markovnikov rule, right? This is anti-Markovnikov rule. How we are going to found this is the whether it is Markovnikov rule or anti-Markovnikov rule. There is a presence of peroxide, right? So obviously this is going to be your anti-Markovnikov rule. According to anti-Markovnikov rule, so the H plus goes to the alkene which has the lesser number of hydrogen, Br minus goes to the alkene which has the more number of hydrogen. So your product going to be CH2, 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 Br. Okay, so this is the all about that question example sums. Example sum. Next we goes to the why the sulfur is not used. Okay, the why the sulfur is not used preparation, okay, in case of alcohol, right? So let's take the example of ROH. It react with Ki. It react with Ki in presence of H2SO4. Okay, so what is our product? It going to be, it going to form Ri plus H2O. Okay, KHSO4 we can expect, but this reaction is not possible. Instead the iodine get oxidized. Okay, iodine get oxidized. So I minus became I2. So we should not use the H2SO4. Instead we can use the H3PO4 So this kind of change is not possible in case of this reaction. Clear? So next reaction, write the different halogen derivatives of propane. Okay, different halogen derivatives of propane. For this I can I write it in the bond line formula? So bond line formula. So here one halogen is there, here one halogen is there. Then okay, then here one halogen, here one halogen, I can write it. So then here one halogen, here one halogen. In case of here one halogen, here one halogen, you know the name of this molecule. Okay, there is a 4 isomers possible. Clear? So then we know, right, in case of pentane, okay, how many isomer is possible? In case of pentane, how many isomer is possible? Okay, mono, alo, isomer possible, right? So first start with, okay, writing your isomers of pentane. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right? So next one more thing is the next one product, this one isomer. Then 1, 2, 3, 4. 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 So totally 8 isomer is possible. Okay, the single monochloro product is this one, right? Then 3 isomer of monochloride. So this is one isomer, this is second isomer, this is a third isomer. Then 4 isomer possibilities. Here one isomer, 1, then 2, then 3, then 4. So totally 8 isomer is possible. I already told you, right, in the previous classes. Clear? So the last question is last. Look here, the last one I will tell you. Look here. So the first one, the second one, then third one, and fourth one. The first one I can write it. So this reaction we already discussed. Double bond O, Cl, Cl. So this Cl join here, this Cl join here, this Cl join. So what is the product? Your in case this one not should be there. So because this is cyclohexane, not benzene. So Cl, SO2 plus HCl. This is the first reaction. When it comes to second reaction, we are going to do photolytic substitution reaction. So in this case, this is primary, this is secondary. Secondary is more reactive. In case of photolytic reaction, Br2 and UV. So your product going to be NO2. Then CHCl, CH3. This is the second reaction. In case of third reaction we have two OH group. One is in the aliphatic position, another one is aromatic position. Okay, so this is your aliphatic position OH. Then one more is here. Okay, so this is not going to be reactive. This is partial double bond character. So should react with HCl. When we heat at the time, the Cl going to bond with, so this become H2. Okay, your product is CH2 Cl. Okay, this not going to react. Okay, in case of fourth one, the HI. Look here, this is CH3. Okay, here no hydrogen. Here there is a presence of hydrogen, right? So if I am using the HI, so this is H plus, I minus. H plus goes to here, right? Here your I go to here. The product is, look here, your product is this one, right? Next, in case of this, there is a two more reactions there. Okay, I will discuss it now. The first reaction, your methyl bromide react with the NEI. What is the name of the reaction? Can you text it in the comment box? Look here, CH3, CH2, Br react with NEI. What is the name of the reaction? Your product going to be iodoethane. Okay, this is the fifth reaction. In case of sixth reaction, so we know that, right, this photolytic reaction only possible here carbon is sp3 hybridized one, sp3 hybridized one. So this here the reaction going to be formed here. Why not here? If it form here, it is going to be your allyl halide. So allyl halide is more stable compared to other halide. Okay, I will stop here. Thank you all. Okay.